We're going to go ahead and look at solving quadratics again by going ahead and factoring them. Now, remember, when we were looking at solving quadratics by graphing, to solve them, we were looking at where you were crossing the x-axis. Now, sometimes you can get a nice, neat answer, like we did on one of them in the last section, and other times you can only get approximations. Sometimes approximations aren't always the best and the most accurate. But we're going to look now at ways to be able to get exact answers. Now, factoring is one of those. But when you are factoring, before you factor, it has to be equal to 0. So you have to have everything on one term or side by itself. Now, over here in blue, you can see that we have the hints from factoring from the last chapter. You always want to start with your greatest common factor. Step 2, if you have two terms, it might be differences of squares, which we have listed here, and how that factors. Or if you have two terms and they're added, it might be sum of cubes, which is the next one down. Or two terms subtracted might also be differences of cubes, which is down here. Typically, if there's three terms like we have in our problem, well, then you want to do your AC factoring. If there's four terms, well, then you'd want to try grouping. So we're going to do our AC factoring. Now your A is 1, your C is 48. You multiply them together, you get 48. And then you want to go ahead and look at things that multiply together to give you 48. That would add together to give you this number right here of 14. Well, you could keep listing these out all the way down until you found it, but in this case it ends up being positive 6 and positive 8. So we're going to go ahead and go r squared plus, instead of going 14r, I'm going to replace it with a 6r plus an 8r, which still is at 14r, plus my 48 is equal to 0. Then I'm going to go ahead and pull stuff out of the first two. Basically, we're down to grouping right now. Pull stuff out of the last two. I'm pulling out a positive 8. Now remember, in this, if both parentheses are the same, you're on the right track. So we're going to pull out that common parenthesis. And then you're going to go ahead and look at what's left. Well, you're left with this red R, and you're left with this plus 8 after you pull that out. We now have two things multiplied together to give you 0. The only way to get 0 when you're multiplying is if the first parenthesis is 0, or if the second parenthesis is equal to 0. And then you want to go ahead and solve each one of these. So you subtract an 8 from both sides, and you subtract a 6 from both sides. And so our two answers are negative 6 and negative 8. So if we did graph this, those are the two spots we'd be crossing our x-axis. And that's for the most part what we do for solving by factoring. So we're going to do the same thing here, but remember, to solve by factoring, you have to have it equal to 0. So I need to get this 15 to the other side. So I'm going to subtract a 15 from both sides, and I get a 5x squared minus 22x minus a 15 is equal to 0. Then you always want to look for a greatest common factor. Well, we know 5 goes into these two, but 5 doesn't go into here. So there isn't a greatest common factor that's going to be helpful. So we have three terms, so we're going to then have to try our AC factoring. So we'll go our A times our C, multiply those together, and you get negative 75. Wow, that's a bad looking 5. And then you want to start listing factors of 75 that somehow end up adding together to give you that minus 22. Now you'll notice here when we add these together, we get positive 22. So that means all we have to do is just switch the signs, and then we have our negative 22. So that's what we want to use to be able to get this. So I'll bring this down to 5 x squared. And then instead of writing this, I'm going to write positive 3 of the x's minus 25 of the x's. And then I'm going to have my minus 15 still is equal to 0. Then we're going to go ahead and pull out our common factor out of the first two, which is an x. Same idea in the second one. Second set, pull out your greatest common factor, which happens to be a minus 5. And we get a 5x plus 3. Both parentheses are the same, so that means we're on the right track. So we can pull out our common parenthesis, or common factor. And then you want to go ahead and look at what's left. We're left with this blue x, and we were left with this minus 5. Since we have it equal to 0, we can set each one of these parentheses equal to 0. Set the other parenthesis equal to 0. And here we get x to be 5. Well, on the one here on the left, we subtract a 3. We get 5x is equal to minus 3. Then we go ahead and divide. So these are the two answers that we were looking for. Quadratics will have at most two answers, because they don't have to touch the x-axis, as we saw earlier, or they could touch the x-axis once. They often cross it twice, but never more than twice. So they would actually cross if you graphed it at these two x values.